next speaker, it's time to move to the second talk. Our next speaker today is Angela Fan from Facebook. Angela is a research scientist at Facebook AI Paris, where she leads the machine translation research team. Today, Angela will talk about multilingual machine translation. Angela, floor is yours.
Awesome. Can I share my screen?
Yeah, please go ahead.
It appears to be, oh, perfect.
Is it enabled now? Okay.
Yes, everyone can see it?
Yes.
Okay, perfect. So thanks everyone for inviting me. I'm really excited to be here. So I want to talk a little bit about machine translation. So before we kind of get into some of the more technical details, I really want to kind of motivate this problem. So when I left China, maybe like 20 years ago, it was very difficult to be an immigrant, right? Like going any place, like in filling out all of those immigration forms, like it was very, very difficult to actually be able to kind of integrate and understand and learn English and everything like that. But this experience is like very, very different today, right? Like now, I can kind of go to Italy and like sit down at a cafe and look at any menu and be able to translate everything. And so kind of the prevalence of commercial translation technology has really changed a lot of the accessibility in the world. And so that's kind of the background for the work that we're doing here today. So I want to start with this slide, which is like, what does worldwide translation look like? And so let me explain this kind of matrix plot. So the color here represents kind of the number of requests. So the darker it is, it means that the more translation demand there is. And each cell here represents basically like a translation direction. So the different languages are put on the X and the Y axis. So for example, like this cell that I've highlighted here represents translation from French to Chinese. And so since I live in France now, but I'm from China, like French to Chinese translation is very personally relevant for me. And so, if we look at what worldwide translation looks like today, there's tons of different translation directions that people actually want translations through. So when my mother texts me or when I want to fill out a document in France, like I want to translate like a variety of different languages. However, if you look at what a lot of actual research focuses on today, and even commercial products such as Google Translate, what they actually do is they translate through English. So if I wanted to translate French to Chinese, what vast majority of translation systems will do is they'll translate the French to English and then translate the English to Chinese. However, like this doesn't make sense for a lot of different purposes, right? If you think about people who are immigrants or just like the vast majority of people in the world, like English is not necessarily a native language for many of us. Further, a lot of times in certain areas of the world, translating not through English makes a lot of sense. So for example, if you think about a country like India, there are over 20 different officially recognized languages in India. And so the government needs to kind of produce like official documents in all of those languages. And same for a large part of the world in Africa, Southeast Asia. And so translating through English is actually a limitation. And
Hi,
yeah,
sorry to interrupt. Can you put it on presentation mode?
it is on presentation mode. You can't see it?
It's kind of small.
Oh, it's kind of small. Okay. Let me expand the screen. How about that?
Yeah.
Okay, perfect. Okay, sorry. I can't actually see what you're seeing, so okay, sounds good. All right.
Go ahead.
So one of the challenges of translating through English is if I translate French to English and then English to Chinese, if I made a mistake on that first step, it's basically impossible to recover it, right? Because the English is wrong and I'm depending on that English to go to Chinese. And so like translating through English, not really like the best idea. And so how do we take essentially the research frontier that exists now, this strong dependency on English, and move it so that we develop translation systems that really reflect like the usage of translation in the world, which is essentially like through a bunch of different possible translation directions. And so historically in machine translation research in the natural language processing community, we focus on what we call high resource languages. So these are languages that people speak very frequently, so English, French, German, but also they're usually because historically, different research organizations have been well funded to work on these. So for example, like German is not really like one of the most spoken languages in the world, but it actually has one of the strongest translation systems because about 20 years ago, this was like very well funded by the European Parliament for people to work on German translation. And thus, like, there's like decades of work in this area. So more recently, we've begun to focus on what we call low resource languages. And these are languages that are actually spoken by literally like millions of people in the world, but they haven't picked up a lot in the research community. So we need to develop a lot of new data sets, understand what's wrong with existing data sets, and expand translation to work on new languages. So a good representation here is like the language Fula, which is spoken in Africa. It's actually spoken by 80 million people, which is like more than France, than French, right? But it has like no existing data set, even though like, you know, so many people in the world speak it. And so what is missing before I get into kind of our solutions, like what is missing? And so one of the challenges is that like, what does it mean to be low resource is like a big question. And existing challenges in the research community to tackle this problem have been like largely limiting. So there's a competition that runs every year for machine translation called WMT. And this year, for example, they focused on Hausa and Icelandic, but they provided like literally like millions of data points to work on these languages. So it wasn't really like properly low resource. Second is that there's still this limitation of like focusing on translating in and out of English. And if you look at the research community, when we think about low resource languages, we're still thinking about like how do we produce in and out of English rather than really understanding like how people use translation in the real world and focusing on those problems. And finally, like we want to work on translation, but there's a lot of things that like come before that, right? Like in order to actually properly produce like any type of model and produce translations, we need to be able to measure quality and so on. And finally, you know, we actually need to be able to build out all of these different models, data sets, and evaluation to understand how well we're doing. So I want to start with this first work, which is a paper we came out with in 2020 called Beyond English-Centric Multilingual Machine Translation. And this really tackles the question of like, why do we translate in and out of English and how do we move beyond that? And so there's kind of three main ways that people tackle the question of multilingual translation. Now, the first two are very common, that we call many-to-one and one-to-many. And so in this world, essentially, it's very English-centric. So we take all of the different languages and we try and produce English, or we take English and we try and produce all of these different languages. But what we're really interested in here is the many-to-many case and being able to translate through like any kind of pair of languages that the user specifies. And so what we model here in this work, kind of the end state of this section of the talk, will be like essentially like a way to translate any direction to any direction in this kind of pattern. And so what we do in this work is try and model 100 different languages in one model, but really be able to go for 100 by 100, so like over 10,000 different directions. And so the first starting point here is data. And so as most of you probably understand, like machine learning is incredibly data hungry. And so if you have a lot of data, then you can produce kind of like a lot of different analysis and a lot of great results, especially when we talk about deep learning or using neural networks, which is like even more data hungry than traditional machine learning approaches. And so historically, translation systems are developed off of, you know, human annotated training data. So for example, in the European Parliament, you know, they had a bunch of parliamentary proceedings. There's a lot of different countries in the European Union. And so all of that data has been, all of those parliamentary proceedings have been kind of translated so that everyone understands them. And so historically, people have just been kind of using this to train all of their translation models. But however, like if we really want to expand to the rest of the world, there's not like a convenient collection of like perfectly human translated data. And so a major question is like, one, can we just kind of scale this effort? And two, like how do we actually best use the data? And so when we talk about scaling this effort of training data, oftentimes you might think, well, let me just pay like 1 million translators to kind of sit there and translate all of the data. So first of all, this is very difficult because it's incredibly expensive and incredibly time consuming. And, you know, it would take forever to reach the volume that is required. So instead, what we do is we focus on essentially automatic data creation to create supervised training data. And so this effort is called CC Align and CC Matrix. And the way it works is that we take data from Common Crawl, and Common Crawl is like an open source dump of the web. So if you ever wanted to like understand, you know, like a bunch of web snapshots, you can download it conveniently from Common Crawl. And it kind of indexes a bunch of like web pages and kind of you can download it. And so what we do is we download all these Common Crawl dumps and then we extract the text from it, like removing the images, the HTML and everything like that. And then essentially our goal is to find content that could be a translation. So how do we do this? After we extract each paragraph of text, we break it into sentences, and then we encode each of the sentences into a fixed size vector text representation, which is similar to kind of the Spotify representations that we were just talking about, but it's purely based on text. And then we try and understand if different text in different languages, if the same text in different languages can map onto each other. So if I have the sentence like, my name is Angela in English and my name is Angela in French, like we understand that those two representations being the same thing, and so it could be a pseudo translation. And so how do we decide what to actually mine? And so when we could try and mine like all different possible language directions, but we found like two strategies the most fruitful. The first is bridge languages. And so this is essentially kind of the major languages of the world, like Arabic, Hindi, Chinese, English, French, German, Swahili. And so these are languages that are commonly already translated in and out of each other. And so there's a lot of like data that exists in those languages that we can mine to create this pseudo translation data. The second is what we call dense mining within the family. And you can think of this as very regionally motivated. So the one I pulled up here is essentially Scandinavian languages. So in Denmark, Sweden, Finland, Norway, they have a lot of text that overlaps. And so you can get a lot of data just kind of mining within that Scandinavian language family. And so let's go through a little bit of results on like how much data we're able to mine. So the y-axis here is in millions of sentences, so quite a lot. You can think about like 500,000 as like a pretty good amount of translation training data. And then the x-axis here is like a bunch of different languages. So the first thing we want to look at is the gray bar, which is essentially the amount of data we can mine if we stay English-centric. And so that represents kind of the current research status. And you can actually see that across all of the different languages, it's actually quite small. And then the orange and the blue parts of the bar chart indicate the additional data that we're able to mine through this non-English centric mining process. And you can see for most of the languages that it adds like a significant amount of data. And so going beyond English, it's not just kind of like for a modeling motivation so that I can translate my Chinese directly to French, but it actually provides a lot more high quality data to produce translation models. And so further, like we want to beyond like finding data, like what if we can't find enough data? And so this happens a lot, right? In many low resource directions, people don't write a lot on the web. So for example, that language Fula that I mentioned that's written by 80 million people, it's primarily used like in many countries in Africa, but people don't type a lot on the web in it. Like there's not a lot of Fula-based websites. And so it might be difficult to automatically create data for that through translation. However, we can use this technique called back translation to add additional data. And the way back translation works is that it's a data augmentation strategy. So if I have like an English to Fula model and I want to create more data, so I can train a reverse model and basically produce kind of like pseudo noisy translation data and use that to do training. And so like for languages that we want targeted improvement for, or we don't think we have enough data, you can see those marked here in orange, like we target that with additional data augmentation. And so let's take a look at some of the results that we can get. So breaking down this chart a little bit, so we have 3 columns that are shown on the right. So the first column is performance when we translate 100 different languages into English. Then the second language is 100 different languages out of English. And then the third column is like 100 different languages, like all of the different pairs that don't include English. So French to Chinese would be part of that. And so we have 3 different baselines that I want to talk through first. The first baseline is forget multilingual translation, okay? Like let's just do bilingual models. So in a multilingual model, we have the promise of basically having one model to represent all 100 languages. But I could also just have like 100 different or 10,000 different models for each of them. So that's the first row here, bilingual baselines. Like if I train a customized model for every single possible direction, that's the performance I could get. Now, the next 2 lines are English-centric models, which represent like the current state of research. So I'm going to translate everything in and out of English. And so you can see that the performance of non-English directions is not very good because, you know, the model was not trained to do that. And then you have like our proposal, which is this kind of many-to-many, the last row that I've just entered. And so you can see that translating in and out of English were basically just as good. And then translating through non-English directions, we are significantly better. And if you're not familiar with these numbers, essentially it's between 0 and 100, and about 50 is like amazing. That's like different human translators are around that quality. And so we're shooting for something around 30 here as like really commercially viable. And the next thing we investigate is scaling the model size. So one of the challenges with multilingual translation is essentially models might just run out of capacity. So this is what a standard transformer based a translation model looks like. And the way standard translation works is that we have a neural network in the middle, which are often represented through this neural network architecture we call transformers. And so those are kind of the gray rectangles. And the way translation works these days is that you kind of input some text. So let's say those are like the little red boxes, put it through your neural network, and it magically produces a translation, which is kind of the yellow boxes below. So now, like similar to the fact that like my phone, like it only has like a certain amount of memory, right? Like I can only store, let's say 1,000 photos on it. Now, if I want the same neural network capacity to be able to represent like a lot more content, like how is that able to be possible, right? Like it only has like a fixed amount of stuff it can remember. And so one strategy that people have really pursued is essentially just making the model like a lot bigger. And so if I just really like blow up the model size and blow up the model number of layers, like I might have a model that looks like this. And so what happens if you do this? Now, the y-axis here is the same metric of translation quality. And on the x-axis here, I've broken it down into different model sizes and different categories. So low resource, mid resource, and high resource essentially mean kind of like what is the amount of training data available. And then the gray bar represents a small model with 400 million parameters. Then the navy bar, 1.2 billion parameters. And then the blue bar, 11 billion parameters. And so if you've heard of models like GPT-3 or like T5 or stuff like that, like it's all based on this scaling effort. And so what happens when we apply to translation? So you can see that for low resource, we actually suffer. The model quality gets worse. And this is mainly based on overfitting, right? Like we just don't have enough data. So if you blow up the model size, the model can memorize all of the training data. And so you actually get worse generalization. But for mid-resource and high-resource language directions, the model performance continues to increase as we scale capacity. And so if you kind of average across all of this and just look at kind of the holistic improvement for all of the languages, you can see that as model size continuously increases, we get better performance. But just like pausing for a reflection here, right? The compute needed to create these models is also extremely high, including like the electricity cost, the carbon footprint, and everything like that. And so like the pause for reflection here that we really want to take is like, yes, we can increase the model size, like we can scale up GPT-3, like we can continuously do all of these things, but like, is it really worth the quality? And so on the bar charts, of course, like you see the quality improvement, but like for a human translator, like what actually, improvement would you actually be able to observe? And like taking a step back, like are there better strategies to do this type of scaling? And so that's why we focus on this strategy called language specific mixture of experts. And so if you think about kind of naively scaling model size in this way, what's the downside? Well, the downside is like, yes, I've made my model a lot bigger and I've achieved better translation quality, but now when I put in an input sentence, I have to use like every single parameter in this neural network. And so I've made it a lot bigger. So everything is like super, super slow, really inefficient, and it takes forever to train, right? So instead of doing this, like, can I basically activate specialized parts of the network that are special to certain languages? And so you can think about this like for Chinese, there are special Chinese characters that you have to learn for Chinese. Same for Arabic, like these languages are written in actually different scripts. So it doesn't really make sense that like I need the entire model to learn like every single language script, right? So what we do here is we activate what we call experts for certain languages. And so instead of having like a block-like architecture, as we showed before, we actually have a bunch of these different smaller neural networks kind of sub-contained in the model. And the way it works is that when I'm translating, for example, the blue language, I'm only going to use the network part that is associated with the blue language, and I'm not going to use the rest of it. And so this allows kind of like, let's say the blue language is Chinese, like parts of the model to really specialize to learning Chinese. And so I can have like a better performance through specialization rather than activating the entire model. And then let's say I want to translate the green language, like now I can use just the part of the network that's specialized for the green language. And so the way it works now is that when I have my coral or red language coming in, I activate kind of some shared component just to learn a little bit of like reading the red input. I activate just the one slice of the red language. When I translate into the yellow language, I still just activate a subslice of it. And so this has very, very strong efficiency benefits, right? Because I only use a part of the model for training. So we train substantially faster. And also when I produce translations, I can actually produce them much faster. And so people are not going to be like waiting forever to get their translation. And so going over the benefits, like here languages get dedicated capacity to specialize. We train a large model, but only one slice needs to be used at inference. And actually this has substantial benefits for actual scalability because it's sparse. So you can easily scale it to something like 100 billion parameters, which at the time I made this deck was like pretty impressive. But now with like, you know, all of these new models, it's actually not that large. And so what happens? So here I want to go over some results. So going over kind of the right-hand side first, like the first column is a number of parameters. So we were talking about like 1 billion to 12 billion earlier. The second column is this metric called words per second, which is essentially like how fast can we produce translations. So you want this number to be as high as possible, otherwise you're gonna be waiting forever to get your actual translation. And then we have our translation results, so we can just kind of break down as like low, mid, or high resource, or again, just like average across everything. And so if we have our dense model, we can see that the performance continuously increases, right? But the words per second, like the amount of translations we can actually produce, becomes very slow. So we go down like an order of magnitude from like 40,000 words per second to like 3,000 words per second. So it's like super, super slow. However, if we actually do our language-specific scaling strategy, you can see that the performance is actually the best out of everything, right? Just look at the last row, like the average number at the end, and the last column is bolded, right? It's the best. But the words per second, it doesn't drop off that much. So it's like a good compromise between having really good performance, but still maintaining like that feasibility of producing translations. And further, like we actually have a lot of improvement by adding these language specific capacity layers. So the y-axis here is actually like the improvement that we get, right? So the delta change. And so you can see for many directions that are commonly used, like for example, Chinese to English, German to English, English to German, like we actually get a lot of performance improvement through this capacity. And the reason is because now we've kind of dedicated specialized capacity for these languages. So if you have languages that have a lot of data, now you can better specialize to kind of have like that model performance really high. And so there's a lot of open challenges ahead, like how much benefit would we really get from scaling? Can we squeeze more out of it, more efficiency? How do we actually do low resource languages, right? A lot of languages are related, so how can we better do transfer learning to kind of learn languages that are similar? And then, of course, how do we create these systems without very, very good evaluation data? And so that's what I want to talk about now, which is this project called Flores, which was released in a series of papers that I've listed here. And so the major question that we tackle in like this part of the talk is like, how do you actually make models without evaluation? So this group is like primarily data scientists. So I think you understand the importance of metrics and measurement, right? Like when you do A/B testing, it's all about like reliable measurement. And when we talk about metrics, it's all about like how are we ensuring that we're measuring the right thing and making sure that measurement is reliable and like something we can really truly rely on. Because after all, if we can't actually measure something, like what is the improvement that we're really delivering? It's just not something that we can rely on, right? And so the major question that we tackle here is like, how do we actually evaluate performance through any direction? So the way machine translation is normally measured is like we had some professional translators sit down maybe like 10 years ago and produce like some data sets that we use as benchmarks in research to understand how we're doing in terms of translation quality. But when we're really talking about kind of evaluation through any direction, we really like don't have quality evaluation data sets, right? Like, you know, how can I evaluate the performance of Swahili to Icelandic translation? Like there are no pair of translators who sat down to do this. And so this is what we tried to do in this project. And so in the Flores project, essentially, we found 101 different languages that really focus on low resource. So over like 65% of the languages that we deliver in Flores are not contained in any other machine translation benchmark that the open source community could use. And so we look at a lot of the languages that don't have translation systems today, and we're like, okay, how can we make sure that people can work on them? The first step is measurement. And so that's what we work on here. Second is this idea of many-to-many, like basically being able to translate not just through English, but to be able to directly measure the quality, for example, of Hindi to Bengali translation. Then third, of course, like we cover a large volume, right, like 101 languages. A lot of existing benchmarks only cover a few languages, commonly European, honestly. And so we really want to expand beyond that and support the development of just large-scale translation systems. Further, we really want to cover a diversity of domains and topics. So this is really important in measurement too, right? Like if I just say I have a translation system, well, like what kind of content can it translate, right? Like just like, for example, if I have a recommender system, can it recommend me Netflix shows, like Spotify music, like, you know, the domain of like the model is very, very important. And so a lot of times translation models are developed to translate news content. And that's just kind of like a historical research problem. But like I want to translate things other than news, right? Like if I talk about my immigration story, like the government documents that I need to be translating are like, they don't look like newspapers. And so I want to be able to translate a diversity of domains and topics. And so when we created Flores, this was like a major goal. Further, we want to evaluate what we call document level translation. And so this is maybe like a detail that's, I'm not sure if this audience is super interested in, but the way translation works today is like, let's say you copy in like 20 paragraphs to Google Translate, it is not translating those paragraphs. It's breaking them up into sentences, translating each sentence separately, and then concatenating them together. However, this creates a lot of problems, right? So let's say I have like, you know, Angela went to the store, like she is going to buy apples. If I translate separately those sentences, then you don't know that she refers to Angela. And so in English, you know, pronouns like she are gendered, right? Like there is a she and there is a he, right? But when we talk about kind of expansion to languages where pronouns are not necessarily gendered, like there's languages where there's kind of like a they, and that's used by default, how would you ever be able to translate that correctly into English when there is like a he or she? And so this is like very, very challenging, and we actually can't resolve this unless we are able to expand to document level translation, where we can truly kind of represent paragraphs. And further, unfortunately, in the research community, you know, people want to publish papers. However, you know, it's not really fair to do tuning on the test set. And so if you just release all of the data, people might be tuning on test. And so we hide the test set. And so there's an evaluation server to measure like a variety of different metrics and also to maintain like strong scientific integrity. And also, oh yeah, we include some metadata so that people can do like other studies that are possibly relevant. And so Flores, in order to kind of hit all of those components, like we go through like a very, very stringent quality control. So the way Flores works is that we selected a bunch of documents to translate that we want to include in our machine translation evaluation set. Then we work with a global network of professional translators to do the translation. The first step after they translate is we do some automatic checking. So for example, were they actually translating, or did they copy paste too much from like an existing translation system? Or like, you know, is the length of their translation like significantly off? Did they accidentally make a mistake and translate only part of the sentence? And if it doesn't pass automatic checks, it goes back to the translator. Then, assuming all of that looks good, then we have a separate translation team that is not overlapping with the first to do a different quality check. And the reason for this is that different translators, they don't always agree, right? So we want to make sure that we're not overly biasing our translation to just what one translator might think. And so we have a separate team that kind of assesses the translation quality. And then this goes into post-editing. So if the separate translation team decides the quality is not stringent enough, we kind of send it back to our initial translators and they produce better translations. And then if everything checks out, meets our quality bar, then we can complete it and enter it into our machine translation evaluation dataset. And so I want to kind of end a little bit with like, where might we go from here after having described our work? One of the other things that I'm very interested in is tokenization. And so I think this is like, you know, very relevant to this crowd, but there's a lot of languages where white space is not kind of like the default tokenizer. And so in English, like a lot of times people just split on the white space, same thing for French, but for Chinese or a lot of other character-based languages, it doesn't really make a lot of sense. Actually, for a language like Thai, there's not even sentence tokenization. So like we often write with a period in English, there are no periods in Thai. So this is like actually a research question of like, how do we actually properly, you know, deal with text of like hundreds of different languages. We also want to move beyond this kind of blue metric that people use for measuring translation quality, which I've been showing throughout this talk. It's actually quite limited. And I think for like a data science crowd, like you understand the importance of like having the right metrics to measure like the right things. And so when we talk about blue, it's really just kind of like a measure of like rough word overlap. But how can we actually qualify, you know, are we producing like toxic content? Is there a lot of gender bias in our translations? And so we really want to move beyond just having one number to just have like a holistic translation quality, right? We want to kind of have like a battery of different metrics that express really at a detailed level, like how good are our translations. Further, like the data quantity is still a barrier. A lot of the techniques that we have been talking about are producing very noisy data, and sometimes the data is not even in the right language. So there was this excellent paper that came out in 2020 where people who speak these languages kind of went through like a lot of these produced data sets, and they were like, this is not even in my right language. And so there's actually like a lot of work to do to improve data quality. Further, actually, I think this might be interesting for this group, is like, what does it really mean to cover a language? So for example, when we talk about a language like Arabic, usually when people say they can translate Arabic, they mean that they can translate like modern standard Arabic. But, you know, like if you speak Arabic, you know that like, you know, Egyptian Arabic is a little different from Moroccan Arabic, which is different from Tunisian Arabic. And like the way you might like text your mom in Arabic is like very, very different from like modern standard Arabic. And this is actually true for myself. So I actually don't speak like the standard precise Mandarin Chinese. I actually speak like a dialect of Chinese as well. And so obviously this translation, it doesn't work for my dialect of Chinese. It only works for like standard Mandarin. And so like, what does it really mean to cover language? And can we make translation systems that can really translate like, you know, your text to your mom and like not just kind of translate like a standard variant of the language? And further, there's a lot of languages where multiple different variants are spoken and accepted in different regions, even in different scripts. So for example, the language Kazakh, it's written both in Latin script, which is commonly used for like English, and also Cyrillic script, which is commonly used in Russian. And so the different parts of the country of Kazakhstan use different variants of the language. And so like, you know, we should really cover everybody and not force people to kind of like adopt one standard. And finally, like we're very interested in kind of making sure that machine translation is actually useful for people, especially when it comes into play for things like language preservation. And so we've been working with a variety of different communities to understand what kind of tooling they need and what would be most useful for them. And so I will end here and like open it up for questions. And I also want to comment that like all of the stuff that I've been talking about in this talk is actually fully open source. So if you want to use these data sets or use these models, you can just go to GitHub and download them. That's like part of our research team's belief that like everything we produce should be for the community. Okay, I will attempt to stop sharing and then go for questions.
Thank you so much, Angela, for the wonderful talk. I received many questions from the audience, but we will have time. Maybe we'll keep some for later. So have you looked into real-time speech translation? I guess that would make all our lives a lot easier if we travel anywhere in the world. We will not have to worry about translating, right?
Yes, oh my God. So real-time speech translation is very, very important to me. I also speak a dialect of Chinese that's spoken only. So there's some languages that are not written, they're only spoken. And so obviously like, you know, actually when I talk to my grandmother, she only speaks this like spoken only variant of Chinese. And so it's very important. I think the challenges of real-time speech translation are that languages come in different word order. So sometimes you won't be able to correctly translate until I finish the entire sentence in my language, and then you flip it into another language. And so that kind of seamless science fiction movie experience of real-time speech is like really hard to achieve. And it's really hard to move beyond like a 3 to 5 second delay. And so it's an active research area and we care a lot about it, but it's like something where I hope in the next 10 years, like we can really make progress because yeah, I would love that to be real.
But I'm curious about a point you mentioned. So you said some languages are just spoken and they're not written. So where do you get the corpus for training then, in that case?
So this is actually very difficult because, you know, many languages are spoken only. I think people are very protective over their vocal data, right? Like if I, for example, like narrated something for my grandmother to read, I don't really want like a company coming in and like taking that personal data. And so we really partner with different people to like professionally collect that data. So like, you know, I could hire you to basically speak in your language a lot. And then like then that data would become and we would license it for research use basically. And so this is like one of the major blockers, like basically ethically acquiring like this data that we're actually using to train on. And so we're mainly focusing also on high resource languages first, so like French, standard Chinese, mainly because already it's a hard enough problem that, you know, like we're not really ready to tackle my grandmother's variant of Chinese, but I would love to call her one day and like be like, this works. But yeah, so this is why I'm passionate about the area, but I'm really hoping that like in 10 years, you know, like this conversation will be very different.
Well, as long as you have the dream, we will be there someday. So I have a question from Sanjay. Is it possible to incorporate grammar rules into transformer models for low resource languages?
Yeah, this is a great question. So actually, I think grammar rules, dictionaries, phrase tables, like those are all really, really important to be used. And when kind of the neural evolution took over, people like kind of forgot about all of the stuff that was done like years ago in translation. And so we're really revisiting a lot of it because I think for many low resource languages, you have dictionaries available, right? But you might not have like tons of sentences. So how do we actually incorporate dictionaries is like a very active research field, I would say.
Okay, question from Shamur. How much the imbalanced data distribution in low versus high resource languages affect the performance of these multilingual models?
Oh, it's huge. So the problem is like, if 90% of your data is English, you never get a chance to learn the long tail. And so actually this is very detailed, but we actually have published papers on like exactly how to balance the data. And so you could just naively kind of upsample the low resource data and like downsample the high resource. But then what happens is like if I only have 100,000 sentences in Wolof, and I upsample it, then the model sees the same sentence over and over again, and then thus it just memorizes those sentences. And then so you can't generalize on the validation set. And so this is a huge problem. And so there's a lot of different strategies we have to offset this. For example, we do like some masking so that the model can't memorize everything. The different batches that we send for translation are like actually different. And so we try and keep it very diverse, which prevents overfitting.
Okay, I actually have lots of questions, but we'll have to end here because we're already short on time. Thank you so
Okay,
much, Angela, for answering the questions. And of course, anyone in the audience, they have questions, they can direct them directly to Angela.
exactly. Anyone, feel free to email me. Always excited to chat. Thanks so much.
Thank you so much. It was lovely seeing you. So